Okay, tonight we're going to be continuing our work in Chapter 3, and we're looking at the section of the chapter that talks about classes and objects. Now, objects and classes, and you guys have probably heard the term object-oriented programming maybe quite a bit, and really never had a true conception of what it means and what it does. There's various forms of programming. The earliest forms of programming, and most of what you've learned so far, is what we call procedural programming. So you have a certain problem you want to solve. You might even go to the trouble of pseudocoding it or flowcharting it, and you usually think in a linear fashion. You think, I'm going to do this, I'm going to do this, I might loop, I might have an if, I might go from this to that, but essentially it's a step-by-step process. Okay, and really, object-oriented programming has that component to it. The difference is that you can set up a structure that can be replicated. And not only replicated, but become a something unto itself. It becomes an object. And we talked about that back in week 1, like, the dog and making an instance of the archetype of the dog, and from the blueprint you build the dog. And each dog has its own attributes. But what happens when you start to build classes that don't just create objects, that actually do something? So you're going to have data that's attributed to that object, but you're also going to have actions that are attributed to the object. Then you have this elegant syntax that allows you to basically utilize those capabilities without having to go through the process of recoding it, or in some cases not even knowing what the code does in the background, but you just utilize it. And if you name everything well, it really accelerates development quite a bit. So you'll understand what the gets and the sets are, and I know some of you have been reading about those already, but it really kind of unleashes a different level of problem solving. And the modern programming world is all about object-oriented. Object-oriented is being pushed into languages even that traditionally don't do object-oriented. Like those of you in the advanced PHP class, that's where we're going next, is object-oriented PHP. Traditionally not a thing for PHP, but it does it. Same with JavaScript. They've leveraged JavaScript now to be able to do object-oriented as well. And that's kind of a new thing in those fields, and the reason that they're new is because they work well. And once you've created something, why reinvent the wheel? That's really kind of what it stems from. So let's take a look at the stuff in the book here. It says that every object is a member of a class. So if you guys remember the blueprint thing, we have a blueprint for a dog, and then we create a dog. So every dog is a member of the class dog. That's the structure of it. And they, give you this is a relationship, so an object is a concrete example of whatever blueprint you're building from. So the idealized vision and the actual object. Once you create that actual object, it exists unto itself. You can use that blueprint to make many, many copies, or many, many objects, or what we call instances. And the process of creating an instance of an object is called instantiation. You gotta love that word, right? If you've ever heard it before. All right, what's one of the big advantages? That last bullet. You can use it over and over again. So once you've created an object, and maybe you've created it for one certain program that you're using, you might find that you can move it to a different program and it works great. In fact, that's kind of one of the goals of object-oriented programming. And that's why we see so much acceleration in program advancement these days, is because people have built things, and instead of going through the process of rewriting it, we just use what's already been built. And then after a while, it comes, basically part of the canon of programming. We don't have to worry about how do we put stuff on the screen. Somebody figured out that problem like 30 years ago. Now we just print line and it goes to the screen. So, example. All right, so sometimes, we're looking at methods here, and it's kind of interesting that they put methods and classes in the same category, or in the same chapter, because, in many books they kind of separate them. But they really do tie in together in that when you create a class, and therefore an object, that has a certain method built into it, you can then leverage that along with the object name. So if I create an object dot the method name and then parentheses, I have this elegant little syntax that instead of having to go pull the code out, drop it into my program, I can just refer to an external file and pull in the method without having to have all that code in my file. So you see the beauty of that. All right, so there are classes that are pre-written. We've been using them all along. And then, as we lose the screen here, excuse me for just a moment, I'm going to pause. Okay, we got it working again. Now I lost my train of thought, but all right, so when we actually start creating objects or classes, we need to, before we can create an object, have the class to create it from. And that's what this slide is about.
You're
So
saying we've already used classes.
we have. Whenever you build a program, it's a class. The programs that we've been building have the main method, so they execute. But what we're going to be looking at today is creating classes that have non-executing components. So in other words, you can compile it, you can code it, but if you tell it to run, it's not going to run because it doesn't run. It's not intended to run. It's intended to kind of be used as a thing that we can leverage within another program. All right. So there's certain ways that we will be naming things. You guys have already seen the keyword public that sits in front of your classes. That just very simply indicates that other programs or files can access it and use it. There are times when we do use the keyword private. The other option is that you can just omit the word public and just use the word class, in which case it's assumed that it's public. So sometimes you'll see examples out on the web, especially with older examples, where people don't put in those access modifiers. So you won't see public or private, you'll just see class. Does it harm the program? No, it works just fine.
And that's true for any class?
I'm not going to say it's true for any class. There's always exceptions, but that's a good question.
So if, in the classes that don't have our main method or in data fields, those are typically private, correct?
Yeah, the data fields are typically private.
But if you don't put something in front of it, private or public, then it's public?
Okay, well, let's not confuse the data fields with the class. Two different things. There's very logical reasons why the data fields are set as private, because once they're inside of a class, that class is being used as a blueprint. It's not an actual object. So it stays private because of that fact. And not that you can't change the values in them, because you do that with the get and the set. So hopefully that makes sense. So they show you a very simple little class structure here. This is something we've already done, writing programs. But notice that the big difference is there's no main method declared, and we have a variable that's listed as private, and this is what we were just talking about, that sits outside of any methods that might be internal to the class. So in essence, a global variable inside the class. So when we go back to that concept of the dog class, and the dogs had like names and breeds and something else, I forget what all the details were. This is what identifies those. So we have certain attributes that are going to have values. So if we were looking at maybe creating a class of student, the student would probably have an ID, a name, an address, etc. And those would all be data fields. And you can kind of think of it really as like a database entry or record in a sense. That's one way to conceive of it. Because really, when we're building, an object from a class, it becomes its own entity. So in essence, it becomes its own thing, and they can all be consistent because of the data that goes into them. So very often, when you get to advanced levels of Java, you'll be pulling data out of a database and dropping it into an object, and then manipulating that object within your program. So there's a correlation there, both with terminology and capability. So there's different terms that we've been using already. The data fields is one that's going to be very important, and then obviously the variables that we were looking at the top, we call those instance variables. I don't usually use that term because when you've created a copy of a class and create the object, basically what it's telling you is that copy or that instantiation carries its own values. That's all that means. So that instance has its own variables. Okay? All right. Now there are those instance variables that are intended to be private just simply for the fact is that we don't want outside things to be able to come in and change them. So once I've created a dog and it's a German Shepherd and it's 5 years old and its name is Sam, we don't want somebody else coming along and changing it because that dog is that because that's what it is. So that's why they're private. You don't want to be able to go in and change that. Then you're, in essence, changing the object itself. Notice that second bullet there, one reason people do classes as well is basically to keep information isolated from other program components. So you might be using a class that somebody else created, and they really don't want you messing with their logic or their code. Or maybe you don't even need to see that code. You just know that it prints stuff to the screen. All right, some more terminology here. Don't get too mired in these because I can tell you that these, at least the first couple of terms there, are not going to be on any test. But it's just kind of interesting to know. The ones that are important, though, are these non-static methods. So what does the word static mean?
Unchanging.
Unchanging. So non-static would mean?
Changing.
Okay, so you're talking about methods that change. Now, why would they change? The two bullets there. If we think about creating an object from a class that has its own methods inside of it, those methods will change. You can do stuff inside those that will cause other parts of a program to change or change unto itself once it's created as an object, provided that it's set to be able to do so. All right, I don't want to mire you in that mud quite yet. But you see all these keywords. Static, anything that's marked as static means, is in essence, that we aren't going to be changing it in its structure. And the book had a nice little way of saying it, probably better than I can ever say it. So they go through and they have this slide here. This is also in the book. It says static is a keyword. It can also be used as an adjective. There's no keyword for non-static items. So if you don't explicitly declare a field or method, then it is non-static by default. All right. Now, remember, that is for methods. Methods are like the equivalent to functions or subroutines from other languages. So typically, you're going to have a method that's going to do something and it's not going to change. And that's, it'll compute the tax, but it won't do anything else. We really don't need it to change. But if we're working with certain types of objects, we may need it to change. But that's not typically going to be the case at this level of programming. So don't freak out to that. All right, so they go through this slide here. I'm going to gloss over this. They're just showing you what is a valid way to name stuff and what is not. We'll see that in actuality. Here's a little bit more build out from the class that we've been seeing already. So we got the public class employee. Then you can see just inside the first set of curly brackets where it says private int employee number. So what it's telling you is we're creating a class for employees. One attribute of an employee is their employee ID number. Okay, they're not presetting a value. However, it should be noted that you could preset a value if you wanted to. You could hard code a value that could later be changed, and we will do stuff like that. So you might be able to generate an employee without necessarily having an ID number for him right away, but you can still get his other information. Right, and later you can populate the ID number. But anytime you have one of these data fields, the typical practice is that you do what they call getters and setters. Now, these are kind of weird, okay? Conceptually, they're a little bit weird because basically their purpose is to allow you to set those data fields to a certain value and retrieve whatever value it currently is. It's typical that when you create a program that you use both. That's the typical fashion. In fact, there's tools out there, when you first learn to code, you manually type it in. And then later on, you'll use Eclipse and you'll set a private data field and you find the spot in the menu, create setters and getters, and you're done. I probably shouldn't tell you that right away.
Why didn't you tell me that before I did that program?
Yes, you have to look through the menus to find it, but it's there. But let's take a look at what it's doing. So if you look at the way they're naming it, now they're naming it in a fashion that matches the data field. That is not actually a requirement. That is a convention because the convention helps you keep track of what you're doing. So if you know there's an employee number, it makes sense if you're going to do a get or a set that it's named similarly so you know which one you're dealing with. All right, let's take a look at the set first. If you can imagine, yeah, it's the bottom one, but I'm talking about that one first because to me that makes more sense. All right, so if I'm in a program and I'm creating an instance of an employee, one thing I might do is I might set the person's ID number or employee number. So what I would do is I might have a little thing out there where I would type, as I'm creating the object, in parentheses, I would say set employee number, in the parentheses I'd go 1, 2, 3, 4. And then when it comes to this particular class, it will look it up, find set employee number. All it does is it takes whatever thing we're passing in, it sets it to the variable that's within the object, and now that object has that value. And then if we want to retrieve that value to do something with it, or just print it, or whatever we're going to do with it, then you use the get. Now in terms of how that would look in code, maybe the best thing to do is actually create some code to give you an example. So this is really rudimentary. Assume that I have a whole program built here. And one thing that I might do, and we're going to learn this, is I have a class of employee, and I need to create a new employee. So what I would do, just like I would to, let's say, declare a string, I would introduce a data type. So really what happens is once we create a class, it becomes like a data type. So I can say, well, I want to create an employee. What type of data is it? Employee. That's what we're making. We're making an employee. What are we going to call it? I don't know. How about employee 1? Okay. And then on the other side of the equal sign, the typical pattern is to say new employee once again. And most likely I would just do this. Okay. And then later on in my code, I can access these methods inside the class by using those names directly. Now this is where we take the conceptual leap, and this is the weird part, because remember the class is the blueprint. When I issue this particular command, I'm creating a new thing that is called emp1 that has all the capabilities of the class, but is not the class. Do you understand? Okay, so for example, if I then wanted to, for employee 1, set the employee number, I could send in my 1, 2, 3, 4, and that accesses the object that we created, and it goes into the method that's inside that employee we just created. It has all those features, and we set his ID to 1, 2, 3, 4. And then if we wanted, for example, to print that out, we might do something as simple as system out print line. And I'm not going to go through the whole process of coming up with a statement, but you would do something as simple as get employee number. But wait, where are we getting that from? We're getting that from emp1, get employee number with parentheses, and then that would pull back that value. Just like that. So it's a little weird, right? Now, if you were just pulling this back and let's say you were not outputting it to the screen, you might do something like create a variable, give it some sort of name, doesn't really matter what it is, and then you would take that value that you're pulling back and drop it into the variable. Okay, so in that sense, really what we're doing is we're accessing an object and the features within it. We're accessing one of the methods within it. We're able to send data back and forth, read data, change data, and leverage whatever tools are inside that object. Okay. It's a little weird at first, but once you get comfortable with it, you'll soar to new heights, I assure you. All right, so they talk a little bit about how to put a class together, and I am going to gloss over some of this, at least in the PowerPoint, because I don't want to spend all night on it. But the data fields would be any of the attributes that we're going to talk about. What should be attributes for something? It will depend. When you're doing your homework exercises, they're going to tell you, set data fields for this, 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 and that. Some of them will say, set the value to a certain value. Some of them they won't, in which case you just leave it open. In some cases you might, especially when you're dealing with numeric things, you might choose to set it to 0 to start with, or if you're doing a string, sometimes you choose to set it to an empty string to start with. And that's really kind of by choice, or necessity. All right, so here they're going on with an additional example, and now they're basically just expanding. So we started with the employee number first, but now we're adding a couple of strings, first and last name, makes sense, their salary, and that's it for right now. So we got 4 data fields. Each one of them is going to have a get and a set. Each one of them is going to have a get and a set. Now, I know that in the previous slide we talked about what the set does, where we send the value in, it gets populated to the variable within the object, and then if we want to pull it back, notice what the get does? It just returns the value. Isn't that interesting? So I'm not sure why you might think of it backwards, because I know that kind of was the question, but when you're getting it from the object. You're setting it, you're putting it in the object. And it's kind of one of these terminology things that goes back a couple of decades. Whoever thought of it was the one that was lucky to have it persist, I guess. But you're going to see that each one of those data fields has a get and a set. And that is the typical convention. There are circumstances, and I know that some of the exercises will not say that you need a set and a get. In some cases, they'll say, do setters and getters for everything. Some of them will say, just do a get, although it might not be that clearly stated. I'll point it out as we encounter them. Now, another thing that you might want to think about is these are pretty simple, really, because we're sending values in, we're setting it equal to a variable, and then later on we're pulling it back. Could I also do other programming statements in there? Absolutely. Absolutely. I could do a bunch of math to it and then store it. I could even print stuff to the screen from there. I could run other methods in other classes. So the possibilities really are kind of like, limitless. But in terms of simple class design, this is really a good example file. Now I kind of already did this with you guys. So they're showing you the procedure of how you declare a new object. And the top approach is an approach I typically avoid because I think it leads to more confusion. I like the second approach. And I know syntactically, when you look at it, it's like, I'm not sure I get it. Why do I have to say employee, some employee, new employee? Because that's how you do it. That's really the answer. So it's just, you're leveraging the language as it's intended. All right. Now, whenever you're setting up an object, the object will grab a spot in memory, just like a variable does. When the program stops running, that object is gone, does not persist. The only way that you could make it persist is to write it to a database or to a file, but that's not really a necessity. If an object that is instantiated on the fly, we instantiate it, we use it, program's done, it goes away. All right.
It's interesting you refer to a database, because when I was looking through the previous slide, you know, I could see basically you were constructing a simple employee record,
Exactly right.
you know, so, I mean, that's a really neat way, to me, the way you related it to something that I've worked with before, so it's a lot more understandable.
Yeah, absolutely. And you guys should have all had database class at this point, or maybe are concurrently taking it. And Sean, that's not by accident. You know, the one topic kind of feeds the other. And one of the reasons is when you create applications, especially at a high level, you're going to find yourself interacting with a database as a rule more than an exception. So when you get to the higher levels of creating code, you almost count on having some sort of a database interaction because you do want information to persist, right? And the other thing that you do is when you write code is you might have information in a database that you want to leverage to do something, and you need to have some sort of a method to pull it out, query the database, drop it into an object, manipulate it, and do what you need to do. So those components are all, you know, key. You know, if you wonder why you have to study all this database stuff to do, you know, web development, you know, development is programming. It is. And anything that like does something on the web, you know, the web is not static, folks, right? You learn how to do like basic HTML, but the web is not static, it's dynamic. And all those technologies require database interaction. It's important in every language you study. So, all right. So we have what we call the constructor method. And really this, oops, right here, you see that, you know, when we do method calls, how they have parentheses that follow? So what we're doing here is we are actually running the constructor method, what we call the default constructor method. So, in other words, we say what data type we're doing, we give it a name, we use the keyword new, and then we use the data type again with parentheses, sometimes with stuff inside, sometimes without. But that is the constructor. So when we talk about a constructor, this is the constructor. This is actually what constructs the object. Okay? So more terminology than anything else. All right, so once you create it, what can you do? You can access it, and it says with its identifier. You already saw me do it, right, with a little snippet of code. So we created emp1, we can use it, and we can use any of its methods. And that's basically what that slide's about. So what's the object? Dot, what's the method? And you can access anything within it. All right. All right, so some of this is a little bit of repeat of what I've already showed you. So you can see that right inside the main method there, they created a clerk and a driver. They're both new employees. And then for each one of those, they're setting the employee number. And notice the syntax. Clerk is an object now. It's got a method built in to set its number, as does driver. And then using the get statement, so this whole statement here, we can pull the information back, and in this case to output it to the screen. And some of the stuff you're going to be doing in your homework is basically just that. You're going to do, you know, what I would call fairly rudimentary object creation, data retrieval, and manipulation. It's really more to get used to the syntax. All right. Another reason we use these, and I was talking about this before, is that by creating an object, you are really kind of isolating the stuff in that object from the visibility necessary, you know, the obvious visibility of the rest of the program. So when they say data hiding, you know, do people really need to know how you created that object? They don't.
How to use it.
Yeah, just how to use it. So what you'll find, and you'll find this as you use Eclipse, if that's your tool of choice, and NetBeans does this too, is if there are pre-created system-level objects and classes, you can hover over the methods and it'll tell you what the methods do, or you can hover over the object and you can see all the methods that are available and then what each one of them does. You know, and if you write your documentation properly, and why do you think the book has you go off to the Java website to look up the APIs? They want you to get in the habit of looking stuff up because you're not going to retain all of it. There's just no way you're going to retain all of it. I still look stuff up all the time. There's a lot that I know, but there's a lot of stuff that's like, why would I bother to try to memorize? All right. So this concept where we're isolating information from other things, or at least the visibility part of it, when you hear the word encapsulation, that's part of what that means in Java. We talked about set and get. I don't think we need to talk about it much anymore. We talked about the constructor. All right, so the constructors, in some cases, like I said, you can pass values in, and the values will take particular actions. We'll see that when we get to it. But you can choose any data type that you would use inside of a regular program and use it inside of a class. And here's where your mind will start to expand, those private data fields can also create their own objects. So if you think about a class that instantiates an object inside of the data field, you guys even know what I'm talking about? So instead of saying like private int employee number, I might instantiate inside there dog rover equals new dog, and I can do that right inside the class. So I can create an object that's creating another object. Now, the reason I'm kind of mentioning this is when we get to our final programming project, you guys are going to be doing exactly that. So you're going to create what they call a superclass and a class. So one kind of builds off of the other, and then we leverage that to our advantage. All right, let's see if there's anything else important in here. I think we're just about done. The constructor method, we already saw that. You can create the class and hard code values in. I already alluded to that as well. All right, this is some more terminology. Here?
Yes.
Okay.
So you have a class and it's got an employee salary. And that was the data field that we saw earlier, correct?
Yes.
Now we're initializing it. So we don't need to,
Okay, yeah, Cindy Lou, I see where you're going with this. I was kind of jumping over it because I'd rather show you in actuality rather than talk about it in concept. But basically what they're showing here is when you do a default constructor, so when you do this type of thing, oops, just don't click. We're not really sending any values in, okay? But when you use a default constructor, you will actually have, at times, depending on how your classes are structured, you may have it set up so that you have inside that class a method, because this would be a method, that would allow you to preset the salary. If it's empty, and we say new employee with empty parentheses, that class will automatically give you a salary of 300. That would be a default constructor. Sometimes the default doesn't do anything. Sometimes it pre-populates specific values. Other times we will set up constructors that will have no parameters coming in, 1 parameter, 2 parameters, 3 parameters, and they all do different things. All of them would be perfectly valid. So we could create new employee parentheses empty or with however many things that we preset.
well, that's overall, right?
Yes, absolutely. Right. I didn't think we were quite ready for the concept, but obviously you've been reading ahead, so, which is good. Or you're actually reading. You know, a lot of people claim to read but never do. But you know, you guys, if you're not in the habit of reading the programming books, you shouldn't feel so obliged to like read it and say, okay, I totally get it. Just read it, grab what you can, and then we'll try to fill in the blanks for you. And that's why it's really a good idea to read before you come to class and try to do the work before you come to class. And that way you know where you're stuck and where to ask questions as opposed to after the fact. All right. Now this is what I alluded to before. So when you create a class, it in essence becomes a data type. Kind of the same way we create an integer. And then, as I pointed out to you, the string really is a class. It's not really a data type. So, but when we do that, we call those abstract data types. So, in the one that we've been looking at, employee is basically an abstract data type. What kind of data type is it? Is it a number? No, well, no, it's abstract. It has many different capabilities. It can do things. It can hold all sorts of values. It's relative to what we're doing in a program. So that also called programmer-defined data type. You will hear abstract data type more often than you'll hear programmer-defined data type. Really still equivalent to a class. So there's a lot of terminology that you're going to hear where the concepts are interrelated and they're referring to the same thing. It's just what people choose to call it. All right, so we're basically done with the lecture portion, thank goodness, and here's the do-its and you don't do-its and the summary, which you can read on your own, and I move into doing some coding.